I will present about the objective for this assignment. The objective for this assignment is to determine the appropriate pipe size and pump specification to ensure efficient operation. For this assignment, it is focused on designing a piping system for a cooling process, which involves the transfer of heat from a condenser to a cooling tower facilitated by a pump. So, what is piping system? Piping system is a tube made of concrete, fiberglass, plastic, metal, or wood is referred to as a pipe. The piping system is the entire interconnection of pipes, including inline parts like flangers and pipe fittings. It's often regarded as a piping system. The piping system also includes tank, heat exchanger, pumps, and valve. The role of piping system for cooling process are vital for maintaining operational efficiency and safety in various industries. Proper design, material selection, and maintenance are critical to ensure this system function effectively and reliably.
The theory and concepts of piping design are rooted in fluid mechanics, essential for efficiently transporting fluids while minimizing energy losses and maintaining system integrity. Key principles include understanding flow regimens, laminar and turbulent, assessed by the Reynolds number, and applying fundamental equations like the continuity equation to ensure mass flow rate consistency. Heat transfer principle, crucial in cooling systems, determine the heat transfer rate through factors like the overall heat transfer coefficient and temperature differentials. Usually, the flow rate dictates the required pipe size to ensure the flow velocity remain within acceptable limits, usually between 1 and 3 meters per second, to avoid noise, vibration, and erosion. The total dynamic head, which is the sum of the static head, friction losses, and minor losses, is very important in pump selections. The net positive suction head available must be greater than the NPSH required to avoid cavitation. The pump power required is calculated, where H is the total head, N is pump efficiency, and G is the acceleration caused by gravity. The methodology for this report is data analysis process, which the calculation is used to find suitable piping size, pump head, capacity, and power that are required by the systems. The second is tools and software, which the simulations is conducted by using the pipe flow experts. The circuit is executed to generate the data. And the last one is data collection process, which the results for pipe selection is collected, and it shows the results for both pipe diameter and material.
For calculation, step 1, we calculate the required pipe diameter based on the flow rate of water. The cross-sectional area of the pipe can be found using formula area equals flow rate over velocity. After we find the area of pipe, we can calculate the diameter of pipe and we got 0.188 meter. Step 2, we calculate the total pump head and we got total of 21 meter. The pump capacity value is the same as the flow rate. Now, we go to the last step. We calculate the pump power by assume efficiency of 0.7, density of water is 1000 kg milli cube, the gravity is 9.81 milli per second. The value of the pump power we get is 24.1 kilowatt. Now, we will be utilizing flow simulation software to design and simulate our piping system based on the selected pipe size of 0.188 meters and the pump specification we calculate earlier. We also choose the steel material for our pipe because the temperature of water is around 30 to 160 degrees Celsius. We have chosen to use Pipe Flow Expert software for this simulation. By inputting our pipe size and pump specification into the software and defining the layout of our system, including the pump, condenser, and cooling tower, we aim to analyze the flow behavior and performance of our system. setting boundaries conditions such as flow rates, pressures, and temperatures according to our design requirements. We will run simulation to evaluate the system efficiency and effectiveness. Our goal is to ensure that the system maintain a velocity below 3 milliperseconds, overcome pressure drops, and achieve the desired temperature reduction in the condenser. Through this simulation process, we will analyze the result to ensure piping system meets all necessary criteria.
Today I will explain about the discussion. From the discussion, relationship between head loss and velocity. The head loss rises in tandem with the fluid flow velocity. The friction that exists between the fluid and the pipe wall is what causes the interaction. Head loss is the result of energy dissipation brought on by the frictional forces. The Darcy-Weisbach equation, which indicates the head loss increase with the square of the velocity for turbulent flow, is frequently used to explain this occurrence. Transition phase value, the point on the head loss versus velocity graph when the phase in which the flow regimen changes from laminar to turbulence is known as the transition. Laminar flows is characterized by limited mixing between layer of moving fluid and head loss that grows linearly with velocity. At the transition point, the flow becomes chaotic and turbulent due to increasing velocity, which quickly increase head loss. Comparison of calculated and measured head loss. Through there could be some variation head loss value determined by the computation and measures frequently compare well. These descriptions may be the result of measurement mistake, theoretical model assumption, or disparity between real flow conditions and idealized scenarios. For the conclusion of our presentation here, in conclusion, the fluid friction represented by this flow can be computed using the head loss and Reynolds number. The friction factor of the larger diameter pipe is substantially higher than that of the smaller diameter pipe. The findings indicate that pipes, fittings, additions, and contraction have an impact on the amount of time considered. Furthermore, the velocity inside the pipe obtained is 3 meter per second. The value of head loss obtained is 21 meter. The pump must deliver the power of 24.51 kilowatt to pump the water through the system. Based on the data obtained, both calculated and simulation are very close. Thank you very much. That's all from me.
Akan aku hadir hanya untuk